Welcome everybody to today's webinar. My name is Blake Jeans. I'm from Structures.Aero. Today we're going to be talking about API optimization, multiple ways to accelerate the running of code. Specifically, we're going to be looking at code that's run over the COM interface today. So this is code that is run from outside of Femap, whether it's being run from .NET, from VBA in Excel, or any other application, things like that. So I'm going to start off with just a quick summary of what we're going over. First, I'm going to give just a quick overview of SDA, who we are, what we work on. Then I'm going to give a quick overview of the COM interface, just some basic background on how it works. Nothing in too much detail because it's not important for what we'll be talking about. I'm going to give a definition of the example problem that we'll be doing. And I'll say it again when we get there, but this is just an academic exercise to make it simple to demonstrate what is going on behind the scenes. We'll give an overview of how you create custom output vectors in Femap. That is what we will be doing today. And then we'll dive into 3 different methods of programming the same problem and do a speed comparison on them, look at the effects of different API calls and how we can get things to run faster. And then we'll wrap up the conclusion and we'll take questions at the end. So we are Structural Design and Analysis, otherwise known as Structures.Aero, and that is our website. We were founded in 1997, and we provide expert aerospace structural analysis to a variety of industries. We specialize in composites, doing strong, lightweight structures that are readily manufacturable. We work on a large range of programs, from small to large UAVs, manned, unmanned spacecraft, naval structures, and we go all the way from low-level support through full test plans and full stress analysis reports. The team here consists of well over a dozen bachelor's, master's, and PhD level engineers. And we're located in Sterling, Virginia, just north of the Dulles Airport, west of Washington, D.C. Some typical projects that we work on, these are all projects that we've supported in the past and or are currently supporting. We've worked on things ranging from the Aurora Excalibur through the restoration that we worked on for Lufthansa. We've worked on the composite crew module all the way through the Orion crew module and the James Webb Space Telescope. We are a Siemens Value-Added Reseller, and we do provide first-line support to all of our customers. We specialize in Femap within Nastran, but we also support Fibersim, Solid Edge, Nastran Enterprise, and Femap. And then we're also a Collier Research Corporation reseller. So for this, we work with HyperSizer. So we do sell and provide support for that as well. All right, so with that out of the way, we're going to go ahead and jump into the presentation for the day. We're going to start with a quick overview of the COM interface. So the COM, or OLE, is a language-neutral method of implementing objects between environments or between programs. So this is the behind-the-scenes method that is used when you're talking to Femap from Excel or from .NET, Python, whatever language you might be using. It works with basically any language that can implement a COM interface. So this allows the transfer of information between 2 differing pieces of software, whether or not they speak the same language, essentially. And for what we're going to be looking at today, we're actually going to be working with Excel, which is a very easy interface, as it's also a VBA interface, so the language between Femap and Excel is identical. So the basics of a COM interface is the same as any other object-oriented language. So for what we're looking at here, I just realized I have that picture backwards. Excel is actually going to make the request to Femap, and then Femap will provide the response. And if we are running an API that needs to make, a million API calls, if you have a large number of elements or a large number of properties, there's a lot of overhead that is associated with this interface. So what we're going to be looking at today is ways to speed this up. There are much more efficient methods of doing these kind of calls rather than making, for example, 1 call per element. if we can cut that down and do one call per property, call things in large arrays, we can greatly speed up the runtime of a program. So you end up with something that looks more like that. Excel will make the request, and again, I apologize, that graphic is backwards. Excel will make the request to Femap, and then Femap will respond back with a large number of data instead of doing a bunch of individual calls. And I think everybody's probably be surprised at the impact this can have in the running of a program. So, like I said, API speed can vary greatly. It depends on a large number of things, but if you're working from outside Femap and over the COM interface, COM calls are your biggest killer. The number of COM calls that you're making has a huge impact on performance due to the large overhead. The difference with this is if you're actually working inside Femap, the effect of this is present, but it's far smaller. Because you're just making a native call inside Femap, there is no huge overhead associated with the COM interface if you're working outside Femap. And we'll go into some of that and the effect that it has on your program. So what we're going to be doing today is develop an API which plots laminate element thickness as a stored output vector. I do want to say again, this is just an academic exercise. This is a native feature in Femap. Although it does not permanently store it as an output vector, it will just display it for you. So if you need it stored as an output vector for some reason, it's certainly possible with an API. So in order to accomplish this, we have to create that piece of output data for every element, because that's how Femap plots data. However, the thickness information itself is not element-based, it's property-based. So that's one of the tricks that we're going to use to make things run faster when we get into this. And there are obviously multiple methods and multiple ways you can accomplish this same task when you're programming an API. And the example model we're using today is just a simple wing box. If you've been to any of our other webinars, you've probably seen this model before. It's fairly small. It's only 37,000 elements. So, I mean, we've worked with models well over 1 million elements. So you'll see the speed benefit that we can gain from this is just exaggerated when you have a much larger model. All right, so the main goal of this program today is to create custom output. In this case, we're going to be taking the thickness from each property and plotting that onto the elements. So the code that you see up top is the brute force method of doing this. So the first line here just sets a value, this is hard-coded for an example, a value of 2,200 onto element 100, and then stores it into the output vector of 9,000,001. So this is something we could put in a loop, we could program and run it. However, I'm sure most people already know that this is not a good way to do things. This is the first example of something that would take, if you have 1 million elements, this is 1 to 2 million COM calls, depending on how things are programmed, on top of everything else that's in the loop. It's going to run extremely slowly. And if you look in the Femap API documentation, they call out directly that the use of helper methods is recommended, so you're not uploading things to the database one at a time. And then just as a side note here, if you were trying to do the same problem and import some data, there are some built-in methods into Femap to import either a CSV or a neutral file. So it might be faster to do it that way. However, what we'll end up by the end of today is a method that will run very, very quickly and gives you a lot of flexibility. So helper methods, what are they talking about when they mention these? So on the left is that manual method that we were looking at, right? We have a set ID, we manually set the value and place it in the output vector. So a helper method are these methods here on the right, for example, the put scalar at element, which deals with an array instead of single values at a time, right? So in this case, it's just a 1D array because we're putting that same value of 2,200 onto element 100, and then placing that into vector 9,000,001. So those two pieces of code do the same thing. However, they accomplish it very different ways. And the one on the right is expandable because we can populate those arrays and then place them into the output vector or into the Femap database in a bulk operation. So instead of making a million com calls, we're making one to place that data in. So if we look back at our initial problem, right, we need to pull the element thickness for every element, or the property thickness for every element, and create those arrays for us to store into the model. So in doing that, right, our first step is going to be to loop through every element. And this is definitely the brute force method. It's simple to understand, it's simple to program, but the cons here, it does require a lot of com calls, which I'll show in a minute, and will end up being very slow. But in this loop, we need to pull the element. That way we can get the property ID. With that, we need to pull the property so we can get the layup ID, because these are laminate elements. And then we need to pull the layup so that we can access that layup thickness property. Then we're going to actually build our output arrays, right? So the element IDs and then the data that we're plotting, in this case, the thickness. And we're just going to iterate that through every element. The bottom part of the program are those same helper methods that we saw previously. Right, we're going to create the output vector. We're then going to populate that vector with the arrays that we've already created, and we're going to put that vector into the database in a single com call. So these last three lines are already optimized. There's not really anything we can do to speed these up. So as we're going through this, these will be constant. We're just going to be looking at that while loop and figuring out how we can speed the process of generating the data up. So if we look back at that loop, there are multiple com calls here, and these are what kill you. Every time it's got to do a com call to Femap, it slows things down. There's a lot of overhead, and there's a great impact on performance. So when we actually run this brute force method generates a total of 335,000 com calls to Femap, and that's only for 35 or 36,000 elements. So if it is run natively inside of Femap on that model, it takes less than a second. It's pretty quick because there's basically no overhead. It's native code in Femap. There's no issue there. However, if you look at the Excel number, it's 150 seconds to run. All of that time difference is overhead with the COM interface. The code that's being run is identical, and the back ends are basically identical. It's just because Excel is outside, every time it has to make a COM call to Femap to pull or push data, there's overhead, and it greatly slows things down. So if you were programming something like this, you're going to think it's just a very intensive program. It's going to run very slow, and if you have a very large model, right, and obviously this could be expanded to things more than just pulling layup thickness. This is in general. If you're running anything element-based, right, it's going to seem slow, but there are ways to speed this up. So let's look at method 2. Right, so this is a property-based approach. We are looking at, instead of pulling the property and the layup objects once for every element, we can rearrange how we run this. Instead of looping through the elements, we're instead going to loop through the properties. So this way, we only have to pull the property data once. We only have to pull the layup once instead of for every element. This greatly cuts down on the number of COM calls, and will greatly speed things up just by looking at the problem slightly differently. The cons here is we have to manage more sets, and that's what happens in these first 3 lines. And the programming logic isn't as clear if it's not well documented, if it's not well commented. So these first 3 lines, we have to actually take a local element set. Right? We've grabbed all the elements we're going to use. In this case, we're just grabbing the whole model. But it's set up that, and I don't have the full code in here, but it's set up such that the user picks the elements they want to process. So in this case, we have to handle that because we don't necessarily want to process that full property or every element that's on that property. It might not have been something the user selected. So what we do is we take a local set, we clear it, we add a rule for that property, just doing the element by property, and then we're going to remove not common with the original element set that the user selected. So this gives us a set of elements on each property that the user selected in the beginning. So this is that extra complication, is we have to handle that. We have to go through that logic and make sure that our selection is still correct and that the program behavior is still correct. But from that point on, it's very similar. We're going to pull the property, we're going to pull the layup, and we're going to pull the thickness. But then we're going to run through every element local to that property and create the same two arrays that we created previously. The end effect of this is we've greatly reduced the number of COM calls that are happening because we don't pull the property and we don't pull the layup every iteration, right, for every element. We just pull them once. Right. So in this case, the outer loop per property only pulled once, much more efficient. The inner loop is still per element, unfortunately. So when we look at this, right, these COM calls that I'm covering in green, they only happen once per property. They're not a big killer because they're not running hundreds of thousands of times. It's just running once per property. It's a much fewer number. However, there are still a few that kill us and end up slowing this thing down still. So if we look at the results for this property-based approach, a very simple reorganization or rethink of the problem, we've cut down our COM calls from 335,000 down to 75,000. In Femap, it's about 1/3 the number of COM calls. In Femap, it runs about 3 times faster. However, if you look at Excel, it's actually running 5 times faster, right? The speed difference that you're seeing there, the extra benefit you get in Excel, is it's all overhead. We've removed all of that excess overhead that was happening, right? So we're down to just 30 seconds for this model. Again, it's not a big model, so 30 seconds could still be a problem if you were trying to apply this to a model that had 1 or 2 million elements to it. Or if you were trying to do something far more complicated, right? It's still slow. It's still going to be potentially trouble depending on what you're trying to do. So there's another step we can take to this. We're still going to go with this property-based approach. It's a good approach to take because it cuts down on the data that we have to pull. You never want to pull redundant data if you can avoid it. However, we'll get to it in a minute here, but there's this get array function in the middle, which is going to help us. So the top of this is identical, right? For each property, we don't change. We still need to somehow get to that layup thickness, which means we have to pull a layup, we have to pull a property to get through the IDs we need to pull the thickness. However, this lookelement_set.getArray, this is a single COM call, and what it does is it returns the number of elements, and then this int ID variable, as I've called it, is the element IDs. It's an array. It's returned as a variant, and we can loop through that the same way we would do the while loop that used to be there, right? So we did while localElementSet.next, looped through it, pulled the current ID, and carried on from there. All we've done now is we pull this array as a single unit. There's a single COM call, returns the entire array back to Excel or whatever you're programming in. And then the loop now has no COM calls in it. So the difference being here, right, we still have all of these COM calls that have to happen to get to the property data, but there are no COM calls in that bottom loop. So the loop that is running per element has no overhead associated with it. It can run natively inside of Excel and not slow anything down. So you'll notice the difference here. Again, Femap, it's native code. The difference is not huge. But in Excel, we're noticing a gigantic difference, right? From the original, Femap is sped up by a factor of 4.5. Significant. But for this program, where it only took a second to begin with, not a huge deal. But Excel, because we've been able to reduce the COM calls from 335,000 down to 600, right? We can run that Excel code now in 0.4 seconds. It is almost identical to Femap. You'll never notice a difference. And it is now not really going to slow down as the model speeds up because the number of COM calls is basically relative to the number of properties, right? But you're not generally going to have 1 million properties in the model. You may have 1,000. This model, I think, only has 10 if memory serves. But the number of properties is far reduced. You do have to do COM calls once per property, but the number of elements is not a huge effect. So the benefit here is we can now run a huge model, be it 1, 2 million elements through this code, and it's still going to be done inside of a few seconds. Very different from the original code, which would take 5 or 10 minutes on a large model to do this fairly simple task. So if we look at a comparison of the methods we looked at here, the brute force is simple to code. It's still relatively fast inside of Femap because there's no overhead, but outside of Femap, whether you're in Excel, VBA, Python, anything that's going over COM, extremely slow. The overhead in COM is going to kill you. When we rearrange it to be property-based, it's a little harder to read. We have to do a little more management of our sets. However, we greatly speed things up. And when we go to array-based, we still have to manage the sets. It's still a little harder to read, but by removing every COM call from inside that element loop, the speed increase can be dramatic. So, a couple of basic rules when you're programming to try and speed things up. If you're programming in native in Femap and it's only going to exist in Femap, COM calls are not a big detail. It's native to Femap. It's not actually a COM call. Doesn't have a huge effect. You can still do things faster if you're trying to do very complicated things, but it's not too bad. If you're programming outside of Femap, anything over COM, the number of COM calls becomes huge. And if you're writing code in Femap that may get used outside of Femap or ported outside of Femap for whatever reason, something to keep in mind. So in general, whether you're inside or outside of Femap, you want to minimize the number of unnecessary COM calls. So from the first example, we were pulling the element and then the property and the layup. So we were pulling the property and the layup object for every element. Not necessary, it's repeated. We could pull it once and then store it for future use, or we can just pull it once and rearrange our logic slightly so we only use it right there. And then finally, when we go to the array-based, you don't want to try and either pull or push data over a COM interface if it's possible to do it as an array. Most functions in the Femap API, not all, but most have array-based features. So for example, that set.getArray. There's also a put array, and they exist for all kinds of different things. There's one for element, one for property. Much faster. The code is a little tougher because you have to deal with the arrays, but if you're looking for speed, it is much, much faster. In this case, which is just a simple example, 300 to 400 times faster to do it as an array instead of doing multiple COM calls. So that's the overview for today. If you're looking for additional resources for learning Femap, this is a book written by one of the engineers here, Eric Gustafson. It's available on his website, learningfea.com, and it is it's not a Bible, doesn't try and be a Bible, but it is a very good learning resource for Femap, and it does cover programming. So it goes into how to write APIs, has some very useful examples in it. And then finally, if you need to contact us, you can contact our salesman at Marty Civic. His email is there. Or you can contact us through our website, Structures.Aero. On the website, you could download a free 45-day fully functional trial of Femap. It has all the Femap capabilities, all the solution sequences included. And that is the end of the presentation. So if there are any questions, I will try and answer them. If there's any that I can't get to, then we will contact you afterwards. There should be a question box inside of GoToWebinar you can type them into. And if you want the slides from today, it should be available in the handout section on GoToWebinar. All right, I have a question. How did I determine the number of COM calls for my tables? That was a very manual process. I took the code that was in there and just basically set up a COM counter, and then every time that I knew there was a COM call, every one of the stars that I put there, I just did a COM plus equals 1 command and displayed it at the end. As far as I'm aware, there's not a fancy way to actually count comm calls automatically. Also got a question, do I have an example of linking Python to an open Femap session? That is a talk in and of itself. If you want to email our support line at support@Structures.Aero, we can give you the information to do that. I'd show it right now, but unfortunately I don't have it on this machine. Alrighty, well, I'm not seeing any more questions come in. If you do have more questions that you'd like us to answer, just email our support line. Again, that's support@Structures.Aero, A-E-R-O, and we will definitely get back to you. Have a nice day.